Consider the chance experiment of rolling a pair of fair dice. List the possible outcomes for this chance experiment, such as 1, 1, 1, 2, and so forth. On these problems, it might not hurt to make a tree diagram if you're not sure. Now, the dice is pretty common, so we know pretty much what those possible outcomes are for the sample space. But if you're not sure how to find that, remember you can create this tree diagram. Sometimes that helps you identify the sample space and the sample size. So when I look at my first roll, it'd be this column. I could get a 1, 2, 3, 4, 5, or 6. And on my second roll, I could also get a 1, a 2, 3, 4, 5, and a 6. They're mutually exclusive. I can't, on a roll, I can't roll. I basically get the same thing, 1 and 1, or 1 and 2, or 1 and 3. And so my sample space, I could have 6 possibilities being 1, 2, 1, 1, and so on. And I'm going to have that same possibility with a 2, rolling a 2 first, and then a 3 first, 4 first, 5 first, 6 first. So your outcomes are really going to be 6 times 6 times for each die. And so my total possible outcomes are 36. Now, I could list them all out, but I'm not going to go ahead and do that here. You would have 36 pairs then of dice. Now, what we're going to get to is, because these outcomes are equally likely, we can calculate the probability of rolling a sum of 5 by counting the total number of outcomes that result in a sum of 5. So when I look at my outcomes, really think to yourself, if you have all 36 written down, you can go through and circle the ones that would give you a sum of 5. Well, I know that a 1 and a 4 would give me a sum of 5 from this first group. I know that a 2 and a 3 would give me a sum of 5. And I know that a 3 and a 2 are going to give me a sum of 5. I know that a 4 and a 1 are going to give me a sum of 5. And those are really it. When I get to 5 and 6, obviously there's not a 0 die, and 6 is bigger than 5. So the possible outcomes for me to get a sum of 5 are going to be 4 possibilities out of 36. Now, depending on what they want you to write it as, they might have you write it as a decimal, rounding to a certain decimal point. This becomes 0.1111. And just be careful in WebAssign what they want you to round to. So if they want me to round to 4 decimal places, I'm going to write it like this. If they ask for a percent, sometimes that might be easier. Usually in WebAssign, I feel like they're going to ask you for a decimal rounded to a certain spot. So this would be about 11%, a little bit more for your chance to get the sum of 5. Now, the next thing would be to do two mutually exclusive events. So the sum, or the probability of you rolling a sum of 3 or a sum of 5. Well, you can't, they're mutually exclusive because you can't roll a 3 and a 5 at the same time for a sum. You can roll a 3 and a 5 on the dice, but you can't roll the sum of 3 and 5 at the same time. So these are mutually exclusive. I can use that property number 3. I need to find the probability of rolling a sum of 5 and rolling a sum of 3. Well, we already did the sum of 5, and that was 4 out of 36. So I'm going to just write that right below that sum of 5. Let's go think about rolling a sum of 3. So my possibilities would be 1 and 2, and really just 2 and 1. So I have 2 out of 36 possibilities of rolling a sum of 3. And if I want to know about rolling either or, the probability of rolling or, then I'm going to use the addition rule because they are mutually exclusive events. So I know this would be 6 out of 36, or 1/6. And again, In WebAssign, if they have you round, just pay careful attention to what they have you round to. So like 0, if they want me to go to 3 decimal places, 0.167, it would be in this case.